Okay, I'll just kick this off. Hey everyone, this is our weekly protocol meeting in which we discuss uh, Soroban and trying to make the design decisions. I think we have only one thing on the agenda today, which is an update on the fees cap. And Nico, can you take it?
Yeah, thank you. And yeah, this is basically like we had like a few conversations in the past few weeks, some more recent updates in the last week, based on some of the convos we had in Discord. So we have a round of updates that I actually published yesterday to the cap, but this is an incremental change on top of the previous thing. So maybe what I can do is kind of give a kind of high level overview of where we are with this the updated fee model, and then yeah, like people are interested and they can go and and go read the actual cap that is has a lot more detail on each of those topics. I don't know if that makes sense, but like we should do
Yeah,
that.
sounds good.
Okay, so so like the thing that we're trying to do in this cap is there are like multiple things in there, but like the one of them that is basically like make all those changes that are required to deal with what Soroban is needs, right? Like so like coming from the classic protocol where we have this flat fee per operation. The operation is kind of the unit of a transaction, right? Like we can have between 1 and 100, and we have this fairly simple model for that in Classic. In Soroban, the resources are a lot more complicated. So you have like compute, you have the amount of bandwidth that you're using, the I/O, like how many reads or writes you're doing to the ledger, and how many bytes. And then you have like even more complicated things in there, like depending on the contract, you have like events that are then potentially that translate potentially into real cost for downstream systems. So like when we look at all of this, we have to think basically in how we can make it that we don't have, in particular, like the spam type of traffic on the network, while at the same time we want to keep fees as cheap as possible on the network. So it's kind of trying to balance those things is what this cap is about. So I think where we left it off, the last time we talked about this cap, the one thing we talked about actually was that we were going to try to make the ledger space something that is actually priced dynamically, and in particular, we are looking at ways to limit the size of the ledger. So this is the topics that we've been having around how do we save data off-chain. That's what Karen presented, I think it was like a couple weeks ago or even last week. So this is one component of this cap. The other things that we are looking at was around like the pricing model basically for all other resources, so like compute and bandwidth, for example. So we've been kind of going back and forth. There was like the first like big iteration around this was to try to come up with a way to do like dynamic pricing for every resource type on the network. And then as we kind of looked into more detail, like it became kind of evident that it was kind of getting quite complicated to try to to model it on the network itself was actually not so bad. I think where things were getting really complicated is when we try to think about ways to prioritize traffic, basically, like when you have like multiple transactions competing with each other, which one gets to be in the ledger versus the ones that are postponed to a future ledger. And so this is already getting complicated on that front, and then there's the other aspect that is, while this is happening on chain for clients, it's also getting really complicated to try to basically decide how to what to bid basically in terms of fees, right, for each of those resource types. So those are like the type of things we've been thinking about in the past few weeks in more depth, right? Like trying to think about ways to simplify this a bit. And at first we were looking at doing something that was trying to kind of come up with like a more, I think I call it in the cap currently, like because it's still you can still see it as part of a more like an appendix type of thing, right? Like a alternate implementation. Yeah, so come up with a synthetic resource that is basically an aggregation of the different resource types that a specific transaction is using. That basically combines and comes up with something that is maybe like similar to the notion of gas that, for example, you find in Ethereum. That work basically that synthetic thing represents compute, but also disk I/O and yeah, like a bandwidth. Any resource really in the system is kind of you try to kind of fit that into this synthetic thing. And then, yeah, so we started to kind of explore that, and what we found is that it was still fairly complicated to try to be fair when prioritizing transactions. Like, you have like certain scenarios where when you come up with like a recipe, right, for this synthetic asset, where you basically, for example, you say, okay, I have like to combine those different resource types, I'm going to take some of the compute numbers that I'm getting. I'm going to give a weight to this and add to that, like with a different weight, the I/O cost, and you combine all those things right into a single number that ends up being your number of this aggregate resource type. And then when you do that, you end up with like very strange prioritization problems now, because if you try to balance, for example, how would you compare a transaction that, for example, does a lot of computation to another transaction that does almost no computation, but that is very heavy on I/O. Like end up with those weird trade-offs where you have to really penalize one of those two types of transactions, and it gets even more complicated when you have like a transaction that does a little bit of both, and then and then you end up with people overpaying a lot for basically getting penalized a lot for using a little bit of a resource that happens to be in demand, while they're also using an expensive but available resource. So this is like the type of problems we are running into. So yeah, which would actually happen like quite often. Like imagine if you have like ledgers being filled with a lot of where the constraint is, let's say, computation, where for whatever reason there's a lot of traffic with where people are doing, let's say, like a trade, right, on against an AMM. So like this one is actually a little bit of I/O and then computation. They're like maybe, depending on the AMM implementation, it could be like something fairly complicated. And let's say you have a lot of trading like this happening. You still have plenty of I/O available to your on the network, but I/O is going to always be expensive with the way we want to kind of to model this, because adding things to the ledger is kind of one of those things where yeah, adding something to the ledger is something that has an impact on many systems. So relative to compute price, adding data to the ledger, yeah, is orders of magnitude more expensive. Kind of like what you see in the classic protocol, where the base reserve is a lot more expensive than just like the transaction fee, right? That's kind of the way to think about this. So then if you ask people, okay, like in order to get into the ledger, you have to bid, let's say, 100 times, the price of your aggregate resource because of congestion on gas, or sorry, on compute. Asking people to pay 100 times for I/O in this case is kind of weird, right? It makes things very expensive for no real good reason. So anyway, so like the latest iteration, what we kind of looked at was how can we make this problem go away? And the current approach that we kind of landed on is to rely more on or pricing resources on something that is more like network parameters, or like automatic and automatic pricing, right, of resources, similar to what was actually already in there for ledger space, where basically if you look at a transaction, you can derive independently from other transactions the price of those resources. And then the type of market dynamics that you have are not actually on the resources themselves, but on, I think I called it the cost of inclusion in a ledger. And I think this is basically shifting the conversation there around why do you want to be ahead of, if somebody submits a transaction, why that person wants to be ahead, right? And I think the name that is used in the literature around that is the social value of the transaction. And the social value has actually nothing to do with the resources, like the amount of resources that a specific transaction is using. It's really based on whatever people are actually doing with that transaction. So in some cases, even though your transaction might be doing a simple set one bit on the ledger, it may be actually something that unlocks like a huge value down the line, right? So there's like decoupling of the two is kind of interesting. Let's see, and yeah, so like this one, like for this to work in a way that kind of makes sense, the assumption that we're making is that we will be able to have like a same way. And when I say we here, it's basically the protocol and validators, right, that are voting for some of those network parameters, such as how much does it cost to store, like, let's say, like 1 kilobyte of data on ledger, like this type of pricing. This is what we're talking about. So, because when you have the price of the transaction, basically you decompose it then into those kind of network-derived fees that are, like I said, like the cost of storing data, for example, on the ledger. plus this inclusion fee, that is an actual bidding per transaction. That's the total fee that you end up paying for. And yeah, so that's kind of the focus right now, is to see how far we can take this idea where the inclusion fee is unrelated to actual resource utilization. So that's kind of the thing we're looking into right now, which is doing like modeling and analysis to see like where this breaks and what are like if this basically holds as a viable approach to this problem. So maybe like I don't know if there are like questions on this at this point.
Yeah, the one other note I want to make here is that like I think besides just prioritizing transactions, just from a user experience perspective, I think it should be a requirement that the user can understand what's going on here, right? And with all of its faults in Ethereum ecosystem, at the end of the day, you know exactly, at the end of the day, there's just like the gas resource, and you're competing for gas. So like the question is, with these new concepts that you're introducing, what is the user experience?
Actually, this is very similar to what you see in Ethereum. I mean, it's a variation on what you see on Ethereum. On Ethereum, your experience is that for a given transaction, you have actually two components. You have your gas price, right, that you have attached to the transaction, and you also have I think we call it a tip or something for the validator that allows you to kind of get included. So there is like something that is similar to this inclusion fee. The difference is that in Ethereum, the inclusion fee is actually tied to the amount of resources that it's a rate basically. It's not a flat fee. It's not technically, it's trying to do more of the dynamic pricing of these aggregate resources, as opposed to kind of stepping outside of that and assume that the price that you actually have, your base price for resources, is relatively accurate. And then this prioritization thing is more about adjusting fees based on like the use cases, right, as opposed to the actual like which limit you're hitting in the system.
Got it. Okay, let's open this up to questions. So if anyone wants to ask a question, please do this on the chat. Or just ask to be included in the stage. Nico, just one more question for you. Like, what are the open questions that you like? Is there anything that you want to consult the team with here right now? In terms of questions that you want help answering?
I think that there are like there is one aspect that is in the cap. I mean, it's around like the which resources we want to allow for refunds. Is kind of an interesting question. Right now in the proposal, I think you can only get refunds for I think it's basically like anything that goes to downstream systems, like basically what gets into Horizon or Soroban RPC right now. It's basically the cost of this of the meta outside of the ledger entry changes. The reason for not giving out refunds for other resources is that right now, if validators make certain decisions, right, that they are not going to include certain transactions because of, we're hitting some limit, let's say on bandwidth, let's say. Actually, bandwidth is not a good example because we know exactly the size of the transaction. But like for compute, right? Like so, let's say a transaction says, "Oh, I'm going to use 10,000 units of compute." Because we are using 10,000 units of compute, that means we don't include up to 10,000 units of compute from other transactions, right? That have maybe the same priority. And then later, let's say that transaction decides, well, actually, I'm going to only use 1,000. But like basically by using less, we would give an incentive to just like like people would just put like maximum numbers on everything, and then the ledger would be kind of idle. Only process this one entry. So I think this is like the reason why we don't want to do refunds on the resources that we think will be highly contentious. But like I wanted to hear like if there are like any opinions on that topic. Let's see. And then the other thing, is around really like the modeling of this prioritization based on the social value of transactions. I think people have maybe like more opinions on this. That would be great because I think like one of the thing that is kind of new in this proposal. So yeah.
Can you offer a bit more information on the social value? I know you mentioned it before, but it's a relatively new concept.
It's not new. I mean, it's not new in the crypto space, right? It's like the idea that a low a transaction that is the importance of a transaction is actually completely independent of the amount of resources it's using, right? Like it can be that maybe it's a simple payment, could be like moving billions of dollars, like when you compare that to a large transaction that does a bunch of stuff, same thing, right? It could be, you don't know, is it doing something that's not super useful, or is it actually a transaction that is related to like a payment channel, right, or a layer 2 type of transaction that is extremely important, right? The value is the inherent value of this transaction is actually off chain in a way.
How would the user determine the social value of a transaction they're about to submit?
Well, it's kind of it's the similar idea than when you're saying, okay, I'm going to bid 2x or whatever the base fee today, right, on the classic network. It's a similar thing where at some point you say, I'm willing to pay up to X for this transaction, right? It's the same idea. It's just like here we're saying we make it completely independent of resource utilization. That's the one difference. But otherwise, the same idea of like in terms of user experience, you want to get people to think about how much they're willing to pay for a specific transaction in absolute terms. They look at it because that's actually not the way people think about it, right? Like when you have you're trying to pay your at a store, right? Like maybe like the way you think about it is not in terms of like, oh yeah, like I want to think about it in terms of relative to the cost of that transaction on this particular network. It's kind of odd, right? Like it's in traditional systems, it's going to be a fee, a percent of your amount. You know, I guess that's kind of a way to think about this. Like that's tied to the actual value, the real world value of this transaction. It has nothing to do with the cost of actually processing the transaction, let's say on the Visa network, right? That flat fee that you can imagine exists, right, is actually not visible to end users, right, in those systems, and it shouldn't be because it has nothing to do with the value of that transaction.
I wanted to say that the problems that we're talking about here are actually not specific to Stellar or blockchain or anything like that. These are standard problems in multi-value optimization scheduling. So this is a thing I spent a bunch of time working on in a former life. So you got the usual problems. You have to decide is there a deterministic relationship between the things that you're paying for and the things that are available. So in our case, it's compute or whatever. But then there's this other aspect, which is how much does somebody need the thing to be done? And that piece is usually not modeled within the framework of the scheduling, because it involves a bunch of, as you say, sort of pieces that are too complicated to be encapsulated, and they have nothing to do with the cost of running anything. So to give you like a concrete example, in astronomy, you have scheduling on telescopes, and you want to do something similar. You want to put observations on these telescopes, and it costs money to do that. So there's a bunch of finite stuff that you have to pay for. But then there's the question of this particular observation I want to make today. How important is it to my science? And that question can't be encapsulated in a general model. It's very specific to my actual use case. So the analog here is, if I have a smart contract, and this thing is very important for my contract to execute, I'm willing to pay more for it. And then so it's very normal to have this as a separate layer. But all the problems that we're going to run into are the same problems that are covered in every scheduling system, right? So this question of determinism, how much does it cost? How do you do a trade-off between orthogonal variables? How do you provide this thing in a transparent way? And then how do you deal with gaming of this social aspect? Like if I have enough money, can I dominate the whole system and basically distort the parameters? So these are like hard problems, but also they're standard problems. I guess that's what I'm trying to say.
Exactly, and that's actually why we ended up where we are now, is that we didn't want to kind of come up with that aggregate resource, right? Like that is basically like, what are the weights, you know, how much weight do I want to assign to each of those resource types to turn this multi-dimensional optimization problem into a single variable, right? And it seems like the most practical way was to actually really couple it, kind of like using your example, right, where you have resources that cost real money, right? Like to run a specific, in our case, right, to execute a transaction, it should cost a reasonable amount, right? That is basically like you wouldn't have like junk transactions being executed on the network. And after that, the second layer is more of a market for getting into that queue. So it's basically like a kind of almost like if you're going to be I don't know, like at the what's it, like the analogy, a good analogy would be yeah, if you could buy your spot in line the day of what's it, like those Black Friday sales, right? Like you're outside the store, you get to get in the line, but once you're in the store, it's still the price of the store. You don't get to, you know, you don't pay more because there are more people, you know, in line inside the store, I mean. And that way you really decouple the two problems.
Yeah, so there are a few fundamental questions that I guess it would be great to get answered. So, like, the first question is these things that we believe are, like compute, for example, is it deterministic enough that we could actually define a cost for that would not vary?
Yeah, I think so. That's kind of the current idea here is to give it a flat rate, basically. Like it's, the amount of compute you use would be a linear function, right? To the cost for compute would be linear to the amount of compute you're using. And then that will tune it over time. I think we can, over time, maybe come up with more complicated models, right? That the system can, that we can follow. But like right now, we are using linear functions for that. And the assumption, is that we should be able to, on a regular basis, have a vote, basically, between validators to see, okay, should we adjust that function because of the patterns we've seen, right, in the, let's say, the last month or something.
I was getting to, which is that if you have a multivariable optimization, then what happens is it's tuned to the environment that you observe, and you tweak these parameters. Like the simplest way is you have a bunch of variables, you stick them together with plus signs, you put coefficients in front of them, and then those coefficients are tunable knobs that you use to decide how to trade off the different orthogonal dimensions. But that can be tuned to a particular workload, but then when the workload changes, that usually doesn't work anymore and you have to retune it. So a key question is, as the kind of things that happen on Stellar evolve, how will we adjust or adapt to that?
But that's the thing I'm saying, is that we are not going to prioritize transactions based on this combination, of things, right? Instead, we are prioritizing based on the kind of perceived, right, like the social value, basically, of those transactions. I think that's kind of the key element to this proposal, is that we don't try to be smart in terms of like trying to kind of force try to fit everything into this linear combination of dimensions, because you end up if you do it like that, you end up in a situation where it's kind of like if you have, like, let's say, a bimodal distribution, right? You have two types of transactions, right, that are on the network, and you try to put a line between them, and no line is going to work. Like, you just end up with, basically, you have to decide, okay, do I prefer the first group of transactions or the second one? And then when you're outside of that, your fees are just completely broken, or your prioritization is completely broken.
I completely agree with that. The other aspect of this is the refund thing that you talk about. I think that another way to think about this is that, to use your analogy of waiting to get in the Black Friday sale, you're paying for the privilege of having the spot in the line or the queue. You're not paying for what's actually you're going to be able to buy when you get in the store. So if I, pay for 10,000 compute units because that gives me the space, and I actually only used 1,000, well, I paid for 10,000 because that's how I wanted to, justify my position in the line, right? So I think it is consistent to not offer refunds, but maybe you can frame it differently as really what you're paying for is not the usage at runtime, it's for your expected usage.
Exactly, yeah.
Any more questions from the audience? So Nico, I understand that there's probably another draft of this coming.
Yeah, there's a pull request that's open. Dima, that is the other person, like didn't have time yet to merge it, but yeah, there should be. I'm hoping to get more feedback from people. Like it would be nice if we can get some help on, yeah, playing with that proposal in terms of the like simulations, right? Like see what happens. Are there like situations where it would behave in ways that are really not not great. Like like the example I used with when you start to combine things, right, where you end up with certain transactions end up being penalized a lot, and my hope is that this proposal doesn't do that. But I would be yeah, very curious to see if there are like things we missed basically in this one. I mean, there are probably situations where the thing doesn't work, right? But like having a better understanding of those situations would be super useful.
Got it. And are there open questions, or is the proposal complete as it is right now, or are there open questions in it?
I mean, it's mostly, yeah, it's mostly there. I would say the open questions left, they're more like the minutia of, transaction set, like what is maybe like going back to like the refundable stuff, maybe we want to have the validator or actually be able to say, to give a hint that if a transaction set, let's say, was put together and there was no contention on anything, then maybe we should be able to give refunds to people. Like there was basically like queues were kind of empty, so there's no reason to basically penalize anything. But like I don't know if that's if this will actually happen in practice, because we tend to see more of queues actually have a bunch of stuff and there's never enough capacity to do anything. But at the same time, like I was saying like earlier, like maybe the contention is all on compute and not on IO. So then if people don't use all their IO, like let's say they, because some of the problems here that I'm talking about is imagine you have a test and set type of contract, right? A contract that basically does a read, and then in some conditions going to update the ledger entry. Well, in this proposal, regardless of what the contract is going to do, if you said you're going to write and you don't write, then you're paid for the write, which is a bit sad. I don't know if it will happen a lot, but that's something that I think may happen quite a bit if maybe in certain like trading type of trading contracts or something like that. For AMMs, I don't think it will happen because we always have like those tiny adjustments to the reserves. But maybe different kind of yeah, AMM. Like I said, it's a test and set type of situation. So I would imagine it should be fairly common in the in kind of the general case.
So this is specific for situations in which, let's say pre-flight determined that you're going to go in one code path, and then, the state changes, and when you actually go on the network, it takes a different code path.
Yeah, like this situation is like when you have like an arbitrage opportunity, right? Like you have people see, oh, I can trade, and then so then when they pre-fly, they see that yeah, I can trade, and therefore they're going to submit the transaction. But then when their transaction gets executed, well, the trade was already taken, so it's a no-op, right? So that's kind of what I'm thinking. I guess in the AMM case, that's exactly what will happen, is that you don't update the reserves in that case because the swap is just not going to do anything. but you said you were going to swap, so now you're paying for that. So yeah.
So in these kind of cases, one lens that's kind of useful to look at it is you have all these things to do and you can't do them all. That's why you have prioritization, right? And so really the question of your algorithm is who loses? Who is going to lose and not get in? And answering that question, deciding what you would like to happen in those situations helps to inform the structure of your optimization, right? So it could be that what we're aiming for is optimal use of compute and I/O, and then the ability for people to really push for it if something seems important to them. And if you have that, if that's your thesis, if that's the lens that you're using, then you can make a decision about whether it makes any sense to charge someone when it doesn't actually happen or not, because maybe it achieves your goals, right? So I think that's like one way to think about how to move forward on this.
Yeah, I mean, at the same time, I think the current cap on that front is it's the conservative version, right? Similarly, when you have like if a contract traps, right now we basically say you don't get any refunds if you trap because you've been wasting basically. You know, you had a promise that it was going to be a super useful transaction, and then it didn't do anything because it crashed. Yeah, let's not bother, right? Trying to refund. Basically, it's kind of going back to what you're saying. Like, we want to encourage people to not submit transactions that are crashing or doing nothing. So maybe the current proposal is the right one. Okay, was there maybe more questions in the chat or something that we should be looking at?
I don't see any more questions in the chat. So I think that unless there's something else that you want to bring up today, Nico, I think we can call it a day.
No, I think that's all I got. Yeah.
So we'll continue conversing in the live stage or the live chat if anyone wants to keep talking.
Yeah, there's a thread is, you know, that's on the regular dev. Yeah. So if people want to post that too. All right.
Awesome.
Thank
Okay.
you.
Thank you very much. Have a great day, all.